So, welcome to the second CTCFT. I almost said second annual, but that would be wrong. It's just the phrase that comes to mind. So today, we got an exciting agenda. We have, so I'm going to talk for a little bit, not that long. And then Jane's going to talk about how the social hour thing is going to work, which is this experiment we're going to try. And then Felix and Eliza will talk about Turbowish and the tokio-console. I'll talk about this work I've been doing trying to come up with Rust design principles. And we'll have some time to discuss. I'm hoping there will be lots to discuss. I'll probably give a little time in between these two, I guess, also. And then we'll wrap it up. Okay, so here's how it works. First of all, we're all being recorded. Keep that in mind. Secondly, if you want to talk, you can, Josh is monitoring the speaker queue. You can just type into the chat, like little wave icon or whatever. And I'll put your name on the list. You can take yourself off, try to keep it orderly. I think it often works well if people keep their video off unless they're expecting to speak, so that at least when Zoom is cooperating, it kind of floats all the people who are talking up to the top and you can just see them. But stay muted when you're not talking, and please don't have really long conversations in the chat because it's really confusing. Okay, thank you. To start then, I'm going to hand off to Jane to talk about the social hour. And I think I could even let you control, but you can just tell me next slide if you prefer.
Yeah, let's just do that way. Just hit next slide. So, this slide, there's not much to add. I think we could skip ahead 2 slides.
Okay.
So first, there is a Zulip thread, and it's like if you go through the agenda, you can get the link. It's in these slides, or you can just hop in Zulip. Say again.
Forgot to mention. Sorry, I'll just briefly mention. Yeah, if you want to follow along with the slides, if you go to the main web page, you can click here, and they're all viewable. So for links and things. Okay, carry on.
Yeah, so this Zulip thread is where we can suggest like ideas for breakout rooms. So we're like not really sure the best way to do kind of like a social hangout via Zoom call. So we're just going to try doing some breakout rooms where people suggest them and then vote on them. So the next slide. So in that thread, if you're interested in any of the ideas, just put a thumbs up react on it. And then next slide. That's pretty much all of it. It's not very complicated. When the regular meeting is finished, I will create the breakout rooms, and then we'll hang out and see how it goes. So next slide. Next slide. Oh no, sorry, previous one. I did not realize you hit next for some reason. Yes, so the goal of the social hour is just to have fun, not really to like do work stuff. So a lot of the ideas are kind of like focused on Rust things, the suggestions, but that's just because that's what we came up with, not because the goal is to do any sort of work. So it can be as structured or as unstructured as you want. It's just a place to chat. And then next. So like examples that we put in is, like I want a breakout room, talk about favorite unstable features, or, talk about a cool crate I'm working on, or you could just, hang out. So, and then next slide, which I think is the last one. So yeah, just note that this is an experiment. We're trying to figure out the best way to do this. So if you have any issues or you can think of any improvements, please let us know. And hopefully it goes well. Thank you.
There's a question in the chat. Felix asks, should we hit +1 on at most one breakout room, or do we get many votes?
I think many votes personally, but we can change that rule if it ends up being a problem.
Approval voting, as many as you want. All right, cool. Any other questions? Okay.
Thank you very much.
Then let's go to the next section. Turbowish, dreams of performance tooling. Felix, do you want to try to control, or do you want me to
I'll try controlling because I think there's some places where it's going to be better if I can hit space to do next slide. You know me with my like trickiness with stepping and stuff. Let's see if I can control. What do I have to do?
I think there's an option called remote control. But I can actually just give it to you, which I have now.
Yeah. Okay.
Oh wait.
Yes, it sounds like you might have done that. I can control your screen, it says. I might be doing that now.
But I think I have to enable like accessibility or something.
Oh.
I could also let you share your own screen if you.
Why don't we have me share my own screen? Because I think that's already set up properly. Whoa. Okay, so let me see if I can do that, or at least share that window that I have it in.
Oh, so now I got to give you permission to
share screen. Yeah.
Bear with us, technical difficulties. How do I do that? There's a way. Does anyone remember how I do this?
Or you know what, Nico? We could just have you hit next.
Oh,
that's the other way to go.
No, I'm gonna make you host for a little while.
So it would be good to figure this out because you're gonna need to let me share my screen when I do.
That's true. Yeah, that's true.
Like,
I'll just make, sorry, Felix is host now. He should be able to share. And then I'll make you host, Eliza.
All right. So hopefully this is gonna work. Yeah. So Turbowish, streams of performance tooling. So here's the problem that we're sort of worried about, or I'm worried about. So we got a lot of people very enthusiastic about Rust, a lot of hype going on. And, you know, we make such amazing promises. And so we got people very excited and they dive in and they prototype. But, you know, the experience when they prototype doesn't always live up to the hype. And they ask, what now? That's essentially the heart of the problem that kind of worries me. The past for us in terms of like the long term of the project, you know, we were mainly focused on trying to, and I mean like the distant past, pre 1.0, our goal was to like meet the needs of C and C++ developers. So, you know, debug info support with like standard dwarf and standard stuff in terms of code coverage and profile guided optimization. That was like the best we could sort of hope to do, and it was good enough. And then the other big customer were the compiler developers themselves for Rusty. So we added some, you know, things to do profiling internally, but that was it. And so now that's what's led us here. And so, you know, I had some informal discussions with various Rust users asking, is Rust actually delivering on its promise with respect to performance? And I got 3 classes of answer. Number 3 might surprise, you know, number 3 will surprise you. I don't know. We'll see. So the first answer was Rust is great. Once I get the code compiling, it meets all my performance needs and the code actually works. That's our favorite customer, right? We love those customers because usually then they start picking at, you know, the details and giving nitpicking about the diagnostics and stuff. And then we love that feedback after that point. Then there's customer B, which is the one I said I was worried about. The one saying I got it compiling and it's not going as fast as I had hoped. What now? So that's the one I sort of already alluded to. But here's customer C. Customer C says, you know, I was struggling here. I couldn't figure out what design to use for my system. I struggled to get it compiling in the first place. And you're asking me now what I think about the performance, but I'm still debugging all the deadlocks I see. And that sort of led me to worry about a whole new thing, which is that our past goal was just sort of, you know, being compatible to status quo and acting like the existing debugging tools that are out there will be good enough. You know, if we can get something that works with GDB or Visual Code or whatever, then that'll be good enough. And that was an attitude born of necessity for the most part. I literally, you know, had a conversation, I'll admit, in my job interview where someone asked me, you know, what about tooling here? What about debugging tooling? And I said, we're not trying to innovate in this space. But Rust has moved on. Rust has branched off from C and C++ quite a ways. And that means we should be broadening our scope. We should be thinking about innovating with our development tools as well as our language. And the other sort of insight here, which came from that customer B, customer C case of the, you know, those responses that I showed earlier, debugging profiling aren't exactly disjoint activity. I mean, they are disjoint activities in some viewpoints, but they're both in service of understanding program behavior. So, you know, should we be actually investing in tools that help us both understand both at once, things that can help us understand profiles and debugging, especially when you're talking about IO type stuff where, you know, something that's arguably a performance issue is actually a logic problem in your code. We're talking about deadlocks or things that are just operating kind of slowly. There's lots of cases where it's hard to know what the line is between a debugging problem and a profiling problem. So Turbowish, the word wish is important there. This is a dream. It's not a top-down directive. Let me have a digression here about dreams and why I'm publicizing a dream. So there was an awesome post that Mara put up, I think it was Friday. It was really recently. It said, Rust is not a company. And in particular, it emphasized this idea that we don't get to choose, for the most part, what our volunteers spend their time on. And we don't hire people, for the most part, to spend time on those tasks. We do hire, there are some people who are getting paid to work on Rust, but the vast majority of the community is not being paid to work on it. And so that crucially means we have to inspire people to act. Impactful leaders inspire others to action, but great leaders also listen. And we all have opportunities to demonstrate leadership on both these fronts. We all have our different social media networks that we like. Some of us are hanging on Discord, some on Zulip, some on Twitter. There's some overlap in various places. All of us should be striving to share our ideas and to listen to those ideas of our peers. And then after digesting all of it, we should amplify the best ones. Obviously, the best way to do this is the vision doc process that Nico has been demonstrating. But I want to, push the idea that, unstructured broadcast has value too. Esteban loves to use Twitter and getting engagement on that front and having people respond. I think that's awesome. So I think that we should be looking at all possible ways to get publicity this way and broadcasting ideas. So I have been publicizing my dreams as a way to excite others about Rust's shiny future. Back to the dream itself. So I made a sort of bunch of documents with a collection of goals, hypothetical user experiences, and a software architecture. They're all in various linked blog posts on my personal blog. And they were all an exercise in working backwards. There's this idea of working backwards. I don't know if Amazon claims to have invented it or not, but it's very much like what agile programming pushes in terms of this idea of starting with the end customer, the end user, and what their experience is, and just then slowly working your way back from that. Perhaps even to the point of just developing something that emulates that experience and then adding features to it. So for me, in writing these documents, I wanted to spell out the different experiences for Rust newcomers versus Rusty developers versus experienced web service developers. They're all in the blog post. As an example of this, I spelled out the idea of a console, something that would show you how the tasks are being scheduled in an async runtime and identifying how they're being blocked, and in particular, help you understand the relationship between tasks and resources. And in particular, then there was a user experience that I documented that was meant to sort of elaborate on this, talking about this developer Abigail, and she has a chess program, and she's seeing some sort of deadlock. And so I want a tool that can actually let you click something and see a directed graph showing you the tasks and the resources themselves. Something like this, something where you've got circles for your processes and boxes for the resources. In this case, like channels that are sending information between the processes, between the tasks. And then when you have a cycle in that situation, that can mean a potential deadlock. I want something that can give me that immediacy of understanding. And then, there's some other stuff in there in terms of a potential design for a system for this Turbowish, for the console itself here, which I see as part of a suite of tools that Turbowish could have, because there's so many different experiences I'm trying to describe that it's not clear whether you could actually fill it all in one tool or not. So the right way to go anyway is to deliver something immediately that covers the most important stuff first. So this was an architecture that I sort of briefly described. This is one way to inspire people, to have textual stories and diagrams. Another great way to inspire people, though, that Carl Lersch pointed out to me, mock-ups, showing the actual experience that someone's going to have. And this was the one that Carl provided. And I'll tell you, Carl basically spent some time putting this together. And then after Carl did it, it was immediate, where people were both the customers, the users we were talking to, saw this and said, oh my God, when can I get it? I want it now. Everything else that I had shown them, there was like text and pictures, not so much. This got people excited, and it directly led to the work that we'll see. And so the point here is that I'd love to claim that these posts that I'm talking about, caused the work that Eliza is going to show you in a moment. But the reality is the Tokio team has been long concerned about these problems well before I started even paying attention to it. They care about profiling, they care about debugging, and they've been championing at the bit to address these problems. So we're going to have a dub of Tokio-console, but because of the timing here and having this whole screen sharing thing, I sort of anticipated I might need to, hand off control. So we'll do it at the end. The links will also be at the end, but basically there's source code for this thing you're going to see, and there's a Discord chat space for it. I hang out on Zula personally, but I'm trying to learn to use Discord better as part of this. The console is only one tool, though, that I have in my dream utility belt. In my mind, there's a whole bunch of other spaces that we could be innovating in. Using the Rust language ownership model to do heap profiling, I think, is a great potential use case, and it's spelled out in one of the user stories. Another area that I'm very, very passionate about is record replay tracing, as some of you may know from presentations I've given recently about RR. So anyway, we can get some of these tools by improving on existing integrations. And that's the so-called easy path, right? Just, making the thing integrates well, like debug info. But actually, it's hard because it requires specialized knowledge of like the compiler and the debug info format, et cetera. Or instead of, improving existing integrations, maybe you need entirely new integrations to work with an existing tool. And yet other things are going to require new tools entirely. And that sounds like the hard path, but the funny thing is that entirely new tools can actually attract enthusiastic newcomers because it's working from the ground up. And that can be very exciting for some people to get in on the ground up on a new code base where everything's still small and shiny and they can have an impact. So that's everything I wanted to say. The crucial points I want to try to get to you is that, we can all inspire, we can all listen. It's important to do both these things. And you should all be publicizing your dreams, the dreams you have, and be evangelizing our shiny futures. And then check out the console, which we're going to see a demo of from Eliza in a moment. And you can find me on Discord or on Zulip. Okay, let's hand off control to Eliza, yeah? How do I do this now, Nico? Or can you somehow wrest control from me, or can I hand it off to her?
I can take it back.
Why don't you do that? Because I don't know what I'm doing here.
Let me know.
I just have to remember how also. But I know I can. Some way.
Okay, we've got a question in the queue from Tyler. Go ahead and unmute yourself.
Yeah. Yeah, so you may have said this, but it went by kind of fast.
Yeah, I was rushing.
No worries. So like one use case we're talking about, me as a developer in Fuchsia, is we need to be able to take a snapshot from like a test that's hung in our infrastructure or something. Or is taking snapshots like a use case that you've
I think it'd be
design
great to
for?
be able
Because we're thinking about it.
I definitely in the software architecture that I was envisioning, I think that snapshots are a potential thing, in particular since we have an event log that's keeping track of. So the architecture that was in the picture there's an event log, and the only question sort of is whether you have the full event trace or not, right? And I can imagine very easily saying if you keep the full event trace, you can get full replay, you can actually investigate the state of the system at that point in time. So it's a question of what level of snapshotting you're talking about, though. Like actually tracing the heap and having a snapshot of the state of your whole object graph, or are you talking about just knowing the state of the events, that were instrumented and not necessarily the binaries themselves, right? So there's question marks there about the level of detail you want to grab, but I think the right answer here is certainly an explicit snapshotting option, or even a checkpoint operation to be able to checkpoint the state of the program and restart it from there could be a potentially awesome thing to put in just put in the standard library. It's something that like a lot of OSs support. Pretty cheap checkpointing at this point. Like I know of other tools like RR that are built on Linux cheap checkpointing. So anyway, that's my sort of off the cuff response to that. I think that snapshotting is definitely a potential area that we should be investing in.
Thanks.
Eliza can take over now. In theory.
Okay, am I in
take
control?
you
It
off.
looks like I'm now in control. So I'm going to share my screen. Oh no! Oh no, my operating system is not supported because I'm using Wayland, and I've never tried to share screens in, oh, that's quite bad. Cool. I might have to pass the mic.
Or maybe, you know what we did? I was worried that we might have an issue here. Is Sean around?
You know what? It's like a super simple demo. Felix, if you want to drive, I can like walk you through it. If you can.
Well, we don't have that much time is the part of the problem. So the easiest thing would either if Sean is here, I would hand it to him because he actually, I think, would be the most ready to do it. But if not, we can just say, you know what, we got to move on because we're already at the 24-minute mark.
Sean, do you have the repo checked out?
Yes.
The latest version of it?
Yes.
do you want to just show off the console for a bit? It's like
You're now host, Sean, if you share your screen.
Cool.
so I mean, I can like talk very briefly about like what we've got here, and Sean can
I
just
think that'd be great. I have Eliza
Yeah.
talk and Sean show.
Yeah. That sounds
Okay,
really
sorry
good.
about this. I had like done a bunch of work and even like blown up my font size and stuff so that it would like be easy to see, but I guess this is my fault for using NixOS. So that's fine. But so what we've been doing is we've been focusing like really specifically on the console use case, and we built sort of a prototype that is like specifically targeting like top for tasks as sort of an MVP. And what we've done is we've implemented it on top of tracing, the tracing crate using tracing events in Tokio. And the events that we're collecting are not really like Tokio specific. Right now it's watching for events with names starting with Tokio because we have not like standardized a naming scheme to allow like other runtimes to have events that are like interesting to the console, but we want to fix that. And Nico talked specifically about he wants to try it on Rayon, for example, and I think it should be pretty easy to do. And so what we've got, if Sean wants to, can you share your screen and show the example app? I was gonna like show the code for it first, and because it's like quite simple and it shows how we're like not actually doing like anything in the application. Oh, it's still building. Okay. Can you like bat the examples slash examples or examples slash app.rs, or just open it? So what we've done here is we've written a tracing subscriber layer that you can add to a tracing subscriber that you're using. And then we've got a pretty simple wire protocol. If you check out the latest version of main, you'll actually see a lot less code. But I guess Sean's checkout is slightly behind. Okay, show it now. So we haven't really done a whole lot to change this example app. It's not really doing anything special. It's just in its main function, it calls this init function, and then it just like spawns a couple of tasks. And those tasks have a big loop where they like wait on a timer, and then they spawn some more tasks, and those tasks all wait, and then eventually those tasks finish. So what I would do is, can you do cargo run example app, and then I would pipe its output to dev null, but it doesn't like super matter. That's just the demo that I like scripted for myself. And it's gonna take a minute to compile because I was expecting to do the demo and I had like already compiled everything, but that's fine. So what we've got here is then we have like a wire protocol, and the tracing subscriber uses this wire protocol, which is implemented using gRPC. And the console application that runs on the command line connects to the app. It has like a port that it listens on, and then the app starts streaming events to the console. And if you want to maybe in another window, go ahead and try to compile, like just do like, oh, it's running. Okay, so you do cargo run, and it has a default port that it connects to on localhost. It also takes like a couple command line arguments, so you can say like, okay, I want to connect to this port, or like on this like IP if it's like on a remote host. But assuming it's on localhost, it just cargo run with the default, connects to the default port, and eventually it's going to build. And this is essentially what we've got here is it's going to look a lot like top, as you can see it does. It's got the controls at the top of the screen, and then what we have here is we have a list of tasks, and they have IDs, and they have a kind, and then we're tracking some stats associated with those tasks. We see the like total amount of time that that task has been running, a busy time. which is like how long the task has been actively being pulled, and then idle time, which is like the amount of the task's runtime that it was not actively being pulled. We have a counter of the number of times the task has been pulled, and then we have some fields associated with it, and that includes whether it's a regular async task, a blocking task, or something else, and the file and line and number where the task was spawned from. And Sean can use the left and right arrow keys to sort of select a column. And if you select a column, it resorts the task list by that. And then what you might see is that some of these have kinds that are bangs. When it's a bang, that means that that task is terminated, and it lingers in the task list for a little bit so that you can still see information associated with it. They would be grayed out, but it looks like Sean's terminal doesn't support that, sorry. There would also be some tasteful use of bold in this, which you also can't see because Sean's terminal doesn't support bold, which is fine. And then if you use the arrow keys, you can, the up and down arrow keys, you can scroll through the task list. So if you want to select one of these tasks and whack the enter key, we actually have a screen here that shows some more details associated with this task. We've got the task ID, total time, busy and idle time, just like on the other screen. Again, we see, oh, this task was actually spawned by Hyper. That seems appropriate. This is probably from the gRPC server that's actually serving this data. And then here on the other side, we have some information about this task's waker. So we see that there are currently 2 wakers for this task. And then we see a count of the number of times the wakers have been cloned or dropped. So as you can see, the difference is the number of current wakers. We see the number of times this task has been woken and the time elapsed since the last time it was woken. And this is sort of where a lot of the like much fancier functionality that we want to build is going to hang off of, because now that we're tracking waker operations like clone, drop, and wake, we actually know like when a task is yielding, it's yielding, and something is like cloning its waker, and that's sort of signaling to the runtime the intent to eventually wake that task. So by capturing the context in which a waker clone event happened, we can actually look at like what resource, like was it a channel, was it some IO resource, or was it like a futures unordered or something, or a timer that you are like signaling the intent to wait for. And then when you're woken back up, we can track where the waker was woken from. And so we can see like, okay, so this task was waiting on any of these resources and it was woken by this one. We can also look at some metrics associated with that. There's a PR that is in flight. It's not quite ready. That's going to add histograms of like pull duration. So you can see like approximately how long these tasks were pulled for, both as the total that we have here, but you can also then see a histogram that we can display on this details screen. And we might have some histograms for like the interval between wakes as well. And we also have some work in flight in Tokio to add runtime metrics that are like giving you metrics about the runtime as a whole, like its task saturation, time between pulls, queue depths, so on. And when that's ready, we'll also be able to consume that from the console. And when we integrate with like other executors such as Rayon, we wanted to be able to expose its own statistics that might not be the same statistics as Tokio. Obviously, they don't all make sense. Since Tokio is an async executor and Rayon is like for data parallelism, you might have very different statistics that Rayon might expose to the console. And we'll be able to track and collect those here as well in the future. I also wanted to show off an ASCII recording that was sent to me by Zahari Dishev this morning that shows some work he's been doing about instrumenting the Tokio timer. So he actually has a branch that I think is not quite ready for prime time that's showing a list of all of the timers and which tasks are waiting for those timers. But that's still sort of a work in progress, and I wasn't going to do a live demo with it because I think that that branch only exists on his computer. Anyway, that's sort of what we've got. I'm happy to answer any questions. Thanks, Sean, for helping out with the demo. Sorry about the technical difficulties.
Thanks, Eliza. I think there are some people in the queue. Josh?
So I was curious how easily, you mentioned the busy time and idle time and what those meant. I wondered how easy it would be to detect things like CPU-bound tasks where CPU-bound tasks shouldn't be. And for instance, you've done a lot of heavy CPU processing on something that isn't in your blocking executor. Here's the longest amount of time you spent, and here's where that time was bounded by, like where it was executing.
We already have the stats to do basically all of that. Oh, here's the demo. Great, awesome. This is just like very cool, and it's like not quite ready for prime time. But as you see, we also have here, he's got a list of all of the timers that are running on the runtime, what kind of timer they are, what they did recently, and so on. But that's still sort of a work in progress. Anyway, to go back to Josh's question, we definitely have all of the statistics to do that already. I think the problem with that kind of like there's really two things, right? There's the stats that you are like discussing, and then there's the sort of diagnostics that we might want to emit, like giving you hints and being like very helpful and saying like, you might have this problem. And the problem with those hints for stuff like what you're describing is that unlike in the compiler where like something is either correct or wrong, right? There's like an error, and when there's an error, we can say this is an error. It's like, it's harder to detect things like, is this task definitely a CPU bound task that it shouldn't be? You need like a set of heuristics. And the set of heuristics might depend on the program and the relationship an individual task has with the rest of the program, like how many standard deviations above the norm is it? And so the problem there is that we would have to have some heuristics that are like generally correct before we can start making like suggestions that people might want to view as actionable suggestions in the interface. But you can definitely do that kind of analysis right now with the tools that we have. You can think about it and you can sort the list. It would be really nice to make it very, very easy for people who are maybe less familiar with these kind of issues to identify them. But that requires like, okay, where's the line for like, this is maybe a problem. And that is sort of, it's a little bit individual to the program. It's a little bit hard to find that reliably, but it's definitely something we could do in the future. It would be interesting work. Are there more questions, or did I spend like way too long answering Josh's question?
No, you're good.
The queue appears to be empty at the moment, unless somebody wants to jump in.
Yeah, otherwise I'll move on to this.
Okay, great.
Thanks very much, Eliza. Felix,
Thanks
did you have
again.
any other things you wanted to say, or are you all set?
No, I'm good.
All right.
Sean is making some kind of emoji appear.
Thank you, Sean, by the way, for jumping in
Yeah,
at the last
thanks
second.
so much. I'm really sorry that I had not apparently tried this.
Well, this is why they like, you know, people just, they have the half-hour thing before conferences to like make sure everything's working, right? This is this kind of thing.
It's not a
Well,
demo
I
if something doesn't go wrong.
like
That's
Zoom
my...
call, so I didn't know that it wouldn't let me share my screen.
All right, so let's go to this last thing. So Rust design principles. What is this? So some of you have seen this, but so Rust has always had like our slogans. You know, we've had stability as a deliverable, or fearless concurrency with Rust, or this fun one that I kind of forgot about until I was reading the blog posts, Rust once run anywhere, abstraction without overhead. And they all were kind of getting at some aspect of our design, trying to communicate out what our goals were and everything. And those were really targeted kind of at the end users, but I think they're also been really useful to us as we do our designs to remember the kinds of things we're trying to achieve. We've also had a lot of really long threads. I think everyone can remember some of these, at least who's participated. These were the most commented RFCs. I love that allow non-ASCII identifiers is #1 by, I think, a lot. But, you know, question mark, catch. And of course, the legendary await syntax debate, 482 comments. I think that'd probably be more if it had gotten auto-locked. But my point is, we've had all these discussions and we've had these slogans, and we've developed, I think, a fairly crisp idea of what Rust's kind of design trade-offs are, what our goals are, but they're not really written down in a kind of concise and actionable way. And I think it would be really useful if they were, because, for example, when we have those long threads, or when we're doing designs, well, first of all, hopefully the threads wouldn't be so long, but we'd be able to cite these kind of principles and put our work in that context, right? So that's kind of what I'm trying to do with this. It's sort of my take, but of what are the things that Rust is trying to do, and how does it, what is the goal Rust is trying to achieve, and how does it actually achieve that? What are some of the principles we use to achieve that goal? This started out as a set of design tenets in the async vision doc. So these are still there. They're like really out of date. When we were starting with the vision doc, I started drafting, well, what do I think the sort of design principles of async are? And then we were iterating on them. And as I iterated on them, it seemed like they weren't really about async. They were actually just becoming about Rust itself, the whole Rust language, or even more like Rust library and tooling. I think there's a kind of coherent set of principles that the whole system abides with. So these are the 6 principles that I have in the current draft, and I'm going to kind of walk through them and give some examples and explain what they mean. And they're all, each one is short, each one has a paragraph. The hope is that you can kind of use that to kind of quickly remember what it's all about. And let me see. Yeah, okay. I don't know, I guess I didn't include, there's also a charter, but I must not have included it. I have a nice charter too, which is what we're trying to do. Let me find that real fast. Where is it? Anyway, the Rust design principles. No. Okay, I can't find it. It's okay. Well, here we go. Just drop that right in there. Can you read that? Maybe. Let's make it bigger. So the idea is what we're trying to do. Rust is an open source community, creating an easy to use language for building safe, reliable programs with consistently great performance. We empower everyone to build systems where resource usage, security, and correctness and long-term maintenance are our top considerations, and we do it with pizzazz. That's the current draft of what we're trying to do, but then the question is, how do we do it? And I think these are some of the things that we've used. And let me explain what they mean. So safety first, this one's pretty clear. Safe Rust code is memory safe, data race free, and free of undefined behavior. This is kind of the top principle. So that's the other thing I should mention, is that these are ordered by, if you should try to achieve them all, but if you have to achieve one more than the other, you should lean this way, right? And so safety is first. And you know, there's a million examples of how we enforce safety, but ownership and borrowing is the most obvious one. And there aren't really any places that we compromise on it, at least if you don't look at our some of the unfixed bugs. And we'll even, you know, break some burstability if we have to fix a bug here. So that's sort of a pretty hard rule. But the next one, the next principle, you can have nice things, is meant to be basically expressing the idea. You could say of it as zero cost abstractions, but I think that the real goal of Rust is that you should feel like you're using a high level language. You should have closures and iterators and all these nice things, package management, but it should meet all the needs and get the low level performance that you wanted, right? And so you shouldn't have to like decompile your code and use some lower level constructs in order to get good performance. Iterators are my favorite example because you can write them. They go as fast as a for loop or even faster since they override binds checks. But in other languages, you know, you would be losing performance because you'd have an object for each of the steps in the iterator. You'd have virtual calls all throughout here, and maybe the compiler can recover it and maybe it can't, right? But we used these techniques that C++ pioneered to kind of step past that. But I think there are just a lot of examples once you start digging in. Async functions fit this definition, right? We're trying to give a high level construct without it costing you performance. sort of decompiling down to the same kind of code you would write in C or what have you. Closures, auto deref, operator overloading. These are all great examples of that. But there are places that we give up on it, right? And it's safety. That's why it comes second. So I think like array indexing in C is faster than it is in Rust because we don't have a way to make that safe without bounds checks that at least that's tolerably nice to use. So that's actually a nice thing. Maybe that will change as we do more work into extended static proving and so forth. But we do, one of the things that we also do a lot, I think is a pretty useful pattern, is when we take away something, if we have to give up on something like bounds checks, we often have a kind of another way to get at it, right? With unsafe code in this case, which allows us to skip the indexing checks and kind of gives us the backdoor. So the next one is transparent and predictable. The role here, I think, is that Rust should not surprise you, right? And that means both from performance, you should be able to kind of tell what exactly a code is going to do when it runs, but also from sort of correctness point of view. You shouldn't find out that, in fact, there's some surprising hidden operation they weren't aware of that changes the semantics of the code. And there are a lot of examples of this. I think the most obvious one is we don't have a garbage collector, which kind of which makes the performance profile of your code not predictable. But there are others, like we decided early on, we weren't going to have any kind of copy constructors, right? So in C++, when you have a function call like this, a common performance footgun is that actually there might be some complex operation happening here. Whereas in Rust, this is just always a mem copy. Now, I think you could argue, and I think it's kind of interesting, having phrased it as transparent and predictable, you could argue that even our current rules are not as predictable as they could be. So this could be a mem copy of an awful lot of memory, right? So it might actually be kind of slow. And then there are other things that we like cloning in RC or something, which are O1, which we don't. So that's a debate. There's definitely some active discussion around these kind of questions, but I think having this design principle written out gives us a little more to talk about. Is that really the principle then? And if so, does that imply that we should tweak the design? Than if we didn't have it written out. So there's a bunch of other examples of places that we try to be transparent. Unwinding, we don't like it because it makes it harder to reason about your control flow. It makes your code less obviously correct. You can't quite tell what's going to happen. That's why we have the question mark operator so that we can see it. We don't like to have implicit allocation typically. There's performance cliffs that come from that. And actually, I was looking through I don't have a link, darn it. I was looking through the lib API guidelines, and there's a whole section of rules about predictability there. So I think which fits directly into this. Things like smart pointers not adding inherent methods. And the reason for all these rules is exactly to kind of avoid surprise when you're using the code. So there are some places that we give up on transparency, right? It's third in the list for me. And I think that's because, first of all, for Rust to be successful, it's great if everything is transparent and predictable, but you also need it to be nice enough to get used. And I think there are some examples of things that are not as predictable as they could be, but that we really need to build and make the system work. One of them would be optimizations like reordering of struct fields and enums. There's things the compiler does. The purpose of them is to let you have nice things. Like we want you to be able to use option without worrying about how fast it is. And so we try to optimize it and we do the best we can, but there are limits to what we can do and it changes sometimes from time to time. And so there's a bit of transparency loss there. The next principle, orthogonal, composable, and extensible. The idea is that Rust in a lot of places and in a lot of ways from big to small is really aimed at having little pieces that you can put together in all kinds of ways. And I think this includes like a focus on portability. So at the highest level, you want to be able to take code targeting one. Well, we want to be able to take Rust code and sort of use it on many different systems, which is a kind of composability, composing it with different architectures and operating systems, but also the way we build the code itself. So some of the prime examples, I would say cargo and crates.io. It's the reason that we emphasized cargo so early on, was that we knew we wanted people to have a set of crates that they could build and combine. And as far as language rules, things like coherence, the reason we have the coherence rules is exactly that we figured it was an absolute imperative that you should be able to take any two crates from crates.io, put them together, and have no linking errors or conflicts or other kinds of things. And there are other systems that were more flexible, but if you took that approach, you wouldn't have that property. And it seemed to us more important to have consistency and composability. So portability, I talked about. I see that as part of this as well, being able to go across architectures. And we often make decisions in the standard library, like we're not going to expose atomics and so forth. And you could go on and on. I think this is a really common principle. The global allocator, minimal standard library, these are things that let us kind of put pieces together and have them work smoothly. There are places that we compromise on it. I think it's mostly to get nicer things. So garbage collections, but in some cases for performance. So garbage collector actually does like make composition easier, but we don't have one because it wouldn't be because of transparency. I think auto traits, we automatically determine if things are send or sync. That's a case where we are, it makes composition a little more fragile than it otherwise would be, but it gives the advantage that you can run things in parallel very easily. And that was kind of the goal we were going for. We wanted Rust to be a language where parallel code just worked. Right? So the next one, almost to the end now, is exposing all the system capabilities. This is pretty clear. Basically, whatever you want to do, we would like to help you do it. We don't want there to be a reason that you have to drop out of Rust and go to C or something like that because you just can't do it in Rust. That said, we sometimes make you declare things and jump through a few hoops to get it, right? So I think the recent addition of the C ABI and the C unwind ABI kind of gets you there. Like, first of all, the fact that you have to declare that you're using the C ABI already is like a little hurdle towards interoperating and so forth. But the C, and then we have another ABI that we're adding for whether to indicate whether or not the C function will unwind. That seems okay because that allows us to have nicer things, right? That allows us to do more optimizations, to make Rust code perform better while still preserving the ability to expose all the system capabilities. I think SIMD intrinsics, there's just a lot of examples, OS string and so forth, that are all aimed at the same concept. And I think the way we compromise on this and why it comes relatively late in the list is there's a lot of things that we support, but only in some ways, right? Like long jump or something like that. They tend to be conflicting between safety and nice things, right? So long jump, we don't allow people to just jump over arbitrary frames. That's because you could say it's for safety. You could also say it's for wanting to support use cases like Rayon that would be invalidated if they could do that. And as far as composition goes, we tend to limit ourselves in the standard library to things that are portable across many architectures, unless you opt in and so forth. And that's kind of compromising somewhat. You don't get all the capabilities of your system right away. You have to ask for them. The last principle, a really important one, is hard to misuse. And the idea is basically Rust has a lot of things to catch bugs, right? So it's not hard guarantees like safety, but it comes up a lot. And I think we kind of encourage you to check for all the edge cases, right? So things like exhaustive pattern matching is a good example. Some languages let you leave off cases and just throw an exception if they happen to occur. We didn't want to do that. I think things like the dead code lints, which catch a surprising number of half-finished refactorings for me, are a good example where we just take the opportunity to go the extra mile and look for problems. And then there's a lot of other things, right? It seems like in general, if we have the ability to, we opt for a little extra checking. There are some places where we've had to compromise, usually for performance. I think overflow checks are my favorite example because overflow and arithmetic is really confusing, but we wanted to so we wanted the checks, which is why we have them in debug, but we knew we couldn't afford them all the time. So we turned them off in release, and it's kind of a, we'll catch as much as we can, right? So that's the list of principles, and I'm taking it here to try to get feedback. I think what I want to do next with these is to, oh wait, this is out of date. I'm going to refresh this. I have a different list of what comes next. There we go. This is still evolving. It's a work in progress. And what I'm hoping to get, first of all, from this meeting and from follow-ons in this, is feedback on which of these things are good, or which parts do you think you might do differently? What, if you were looking at your team's work, what might be different? But I'd also like to really just try applying these principles as we go, as we're looking at new designs, to say, do these principles fit? Is there a principle that we're leaning on that's not in the list? And can we add it or describe it in some way? One challenge is trying not to have too many. It's easy to get a really long list, and then it starts to be less useful. So yeah, I'd love to hear, we have a few minutes, if we have either ideas of things that aren't in here, questions about why the ordering is the way it is, counter examples, whatever you got. I'll just leave this on the screen. Looking over at the queue, I see Felix. Felix.
Yeah, so I want to sort of add to me that integer overflow example in terms of you know, we do turn off the overflow checks, but we do also say, you know, in release mode, it's still a consistent portable semantics in terms of it being, it's going to always be modular arithmetic and not be undefined behavior, which I think C doesn't guarantee. So I'm curious how you define that in terms of these principles, if that's under the transparent predictable, if it's under nice things. It definitely seems like something was being valued there over just being hard to misuse, and it wasn't just hard to misuse.
Yeah, I think I would call that transparent and predictable. But it's an interesting question. It's also, yeah, I was gonna say it's also kind of hard to misuse, right? Like it's giving you, it's not really hard to misuse, but it does at least give you the ability to know what's gonna happen, to reason about those cases too. But it's a good one. I'm gonna write it down. I think it's transparent and predictable though.
So Robert Jacobson had an item in the chat, and I'd like to encourage Robert to vocalize it for the meeting.
Yeah. So you know, as we talk about these compromises and principles and ways that we are not compromising, it occurs to me that it would be interesting to have an atlas of where these compromises have been made in the past, or where they have explicitly not been made in the past. You know, the idea here is, I think it would be useful in general just to understand what these principles are and how the community understands them, but also moving forward, you know, to what extent or when or how we should align the choices we have to make with the choices we've made in the past.
Yeah, that's really good. One thing I want to say that I didn't show, but that I've been working on, is this crazy spreadsheet, which is trying to map out a lot of examples, because I was trying to figure out the ordering in a more complete way. So it has, you know, okay, where does having nice things win over other stuff? But that would be something to digest offline, but I'm not sure if that's the kind of atlas you're thinking.
Yeah, that's really cool. I really like that, actually.
Okay, cool. Josh?
I had a quick item. We've used the term orthogonal many times in the context of language design. In particular, things like, if you've learned feature A and you've learned feature B of the language, you should understand how they work together without any special cases. Is that the same principle of orthogonality here that you're talking about, or is there any context difference there? I wanted to make sure.
No, that's the same principle. I didn't mention it in the slides, but I do see this as like all the way down to the granularity of like a particular like question mark operator should compose well with other operators in the language, up to, you know, your program should compose well with different operating systems. They're kind of all on a continuum for me.
Awesome. Esteban had an item regarding the principles and where they might want to appear.
you want me to read it, Esteban?
No, I can ask it. So
Okay.
I was thinking, should these principles maybe be part of the RFC process as well? We already asked things like, how do we teach this feature? And all of these things seem to be like, it could be a good checklist in every RFC going forward.
That's a good question. I don't know. I think that I definitely would plan to use them in that way, like when thinking about a language feature or other feature to kind of go over these principles and see how it measures up. It might make a nice addition to the RFC. Think about that.
Okay, Jubilee.
Oh, and then we gotta, we'll take these questions and then we'll end it. Jubilee.
If you're having audio difficulties, do you want to type? Oh, go ahead.
Oh, okay. Oh, something I just noticed that, like, in general, that tends to be a concern that tends to have kind of like cross-cutting over these things. That is part of Async Rust. So is also this, that it's in many ways it's like kind of it has the advantages of kind of starting over, so that it is very concerned about exposing all the system capabilities and all the capabilities of a processor, and being very portable for processors that people actually still use, which is that processors that are mostly still in some kind of production, I should say, at the current moment, as opposed to the interesting nuances of historical things that are embedded permanently in C forever, because they had to be portable across that.
Yeah, that's why I wrote mainstream here. It's exactly trying to get at that point, that it's not portable across every possible thing, but across the things we think people use the most. Especially because that does impose there's an interesting thing here of like, if you hold everyone up and force them to have a certain level of kind of support and compatibility, or not force, but encourage, it is a kind of tax on everyone. They have to do a little extra work, but everybody benefits because they can combine more things. And so we want to kind of draw that line at the right spot, right? I think.
Absolutely.
Sean?
Yeah, so I think many of these design principles are around kind of the technical parts of Rust. One thing I was thinking about it that I've heard many people call one of Rust's superpowers is its community. Would it be even worth having a sort of something about the community, the well-being of the people that are contributing, mechanisms where we might say at some point, you know what, we're going to stop trying to make this even better because it's going to burn out everyone, or something like that.
It's a good lead in, Sean, because I'm also iterating on a set of community principles.
All right.
So yes, I definitely think that's worth having. I kind of separated them out because I thought it's nice to talk about the design that we're shooting for, and then separately talk about the processes that we use to sort of meta processes that we use to get there. But yeah, good question. All right. So I think we're going to call it now. We're 3 minutes over. Thank you all for staying here, but don't leave just yet, because I've got Jane coming up next. So first of all, I just want to say the next meeting will be July 19th. There's already a calendar invite. If you want to, you can subscribe to the calendar, or I can add you to it, whichever is easier for you. Just let me know. And I don't have an agenda yet, but we'll announce one. If you'd like to speak, get in touch. So let me hand off to Jane, and we'll see about this social hour.
Yeah, I'm going to drop the link again in case anyone still wants to vote. We didn't really get much of the vote, so I'm not sure if that's not what we're going to do in the future, but for now I will just make a couple of rooms.
All right, you are now host, Jane. Let me stop the recording too.
you see an option to make